All right, we are recording. We are live. All right, so we have two more classes today and then next Tuesday, and that is it for new material. Everything else, that'll be the last day I teach is next Tuesday. So these 2 days, we're going to be learning how to solve quadratic equations. Today we're going to learn the first method. Next Tuesday we'll learn the quadratic formula, and then we'll be done for the year. I tried to give you guys as much material as I could given the circumstances. I gave you what I thought was most important. I left out some stuff. So if you see stuff next year that you're unfamiliar with, maybe ask your teacher, say we didn't cover this last year. But I'm hoping that won't be the case because I've covered pretty much all the important stuff. All right, so we've learned how to graph quadratic functions. We've learned how to factor them. Now we're going to learn how to solve a quadratic equation. So everything we've done up to this point has really led us to solving. Everything in the past that you've solved, for the most part, has been linear equations with one variable. We've graphed quadratics, but we haven't solved them. So now we're going to learn how to solve them. So today's method is we are going to solve quadratic equations by factoring. All right, so we need all those skills that we learned about factoring in order to do this. So let's look at a problem here. Okay, so I'm going to show you guys some steps to, man, that glare is really bad. Hang on. That's better. Is that better? I feel like it's better. Can you guys see okay? Yes, okay, perfect. All right. All right, so this is a quadratic equation. Well, what makes it quadratic? If we were to FOIL this out, we'd end up with an x squared, and we know that x squared makes it quadratic, all right? So what makes this an equation is this equals to something. Up until this point, we've done f of x equals, but we didn't have a value really for f of x. We had two variables. We had x and a y, an x squared, an x and a y, okay? Now the problem's telling us that y equals 0. So basically what it's asking us to do is it's saying what value or values of x will give us y equals 0. All right? And here's the process. We're going to use something called the zero product property. And the zero product property says that if you multiply two things together, so we're multiplying two things together and we're getting 0, right? So let's just call this A and we'll call this B, all right? What can I multiply together to get 0? What are the possibilities of these two numbers? All right. So first of all, they could both be 0. This could be 0 times 0 equals 0, right? Okay, that's the first possibility. The second possibility would be that A could be 0. If A is 0, it doesn't matter what B is, because 0 times anything is 0. So A could be 0 and B could be negative 400. It doesn't matter. So this 0 times negative 400 would be 0. All right. The other option is that B could be 0. If B is 0, it doesn't matter what A is. A could be anything. A could be positive 42. 42 times 0 would be 0. So if A is 0 or B is 0, then the whole thing is 0, right? So basically what we're doing is we're trying to find out how can we make this 0 or this 0. And that's what we're doing up here. We're trying to find out what can we do to make this 0 and what can we do to make this 0. So when we solve a quadratic equation, we're actually looking for two answers. And quadratics have two answers most of the time. All right, so let's go ahead and solve this. To solve this, we want to make this equal to 0, right? So we're going to literally think of a number, minus 10, that'll give us 0, all right? And we can set this up as an equation. X minus 10 equals 0. Okay, so what minus 10 equals 0? Well, the answer is 10. So we could solve this. We could do plus 10 on both sides. And we would get x equals 10. So this is our first solution. X equals 10. That means if x equals 10, then this whole equation equals 0. All right? Well, let's plug that into here and see what happens. All right. So x is 10. 10 minus 10 is 0. And 10 plus 20 is 30. What is 0 times 30? 0, right? So it makes the equation true. So this is a solution. All right. But like I said, this could be 0 or this could be 0. So what number could I put in here to get this to be 0? Well, the answer is negative 20, right? All right, but let's solve that anyways. X plus 20 equals 0. We subtract 20 from both sides, and we get x equals negative 20. Okay, that's our other solution to this quadratic equation. So let's make sure it's a solution. Let's plug it back in. What is negative 20 minus 10? Well, that's negative 30. And what is negative 20 plus 20? 0. And what is negative 30 times 0? 0. So this whole thing would be true if that was the answer. So our actual solution is these two numbers. We have two number solution. All right. Now, how do I write my solution? I don't really want to write it with parentheses, because if I write it with parentheses, doesn't that look like just an ordered pair? Well, it's not. It's not an ordered pair. We don't want it to look like an ordered pair. So we shouldn't use parentheses. You should either do no parentheses, or you could do brackets. Brackets tell us that there's a list of information coming, not an ordered pair. Okay. Or you could leave your answer like this. Now, in the computer, I'm not exactly sure how they want you to write your answer. My guess is with no brackets, no parentheses. But read the directions and see how they want your answer displayed. Okay, so we've solved our first quadratic equation. These are our answers. All right, now, it's important that we understand what it is we found. Does the order in which you put the numbers matter? Whenever you write a list out, you want to put the smaller one first. So I always put the negative one first. Okay, cool. The order doesn't really matter, but you should put the small one first whenever you're listing something out. All right. We just found a solution, but it's really important that we understand what that solution means, because you can find solutions all day, but mathematically you need to have an understanding of what it is we're actually finding. So the best way is to visually see what we're finding. So if we were to take this equation and graph it, well, what would it look like? Well, we can't graph it in its current form because there's no y, right? So instead of graphing x minus 10, parentheses x plus 20 equals 0, let's make that 0 just y, or f of x, okay? So remember our solution is negative 20 and 10, right? And I'm gonna write x equals negative 20 and 10. Just keep that in mind, all right? So if I were to graph this, and I'm not gonna actually graph this, take the time and draw a nice graph, but I just wanna show you this. If you were to graph this, you'd have a parabola that looks something like that. And this point here would be I have this backwards. Okay, this point here would be 0, 10. And this point here would be negative 20. This would be 10, 0, sorry. Negative 20, 0. So when we find the solutions to our equation, what we're actually finding is called the x-intercepts. These are the solutions. When y equals 0. And if you look at our equation, y equals 0. So when y is 0, we're finding our x-intercepts. So when you guys take your SATs in high school, you're going to have questions like this. And it could ask you, what do these 2 points represent? And the answer would be they represent the solution of the equation when y equals 0, or we call them the solutions. Okay, your textbook might refer to them as the solutions, those 2 points. All right, now, one more thing before we go to the next example. Look at these two numbers, negative 20 and 10. How did they relate to the original equation? Well, here was minus 10, right? But the answer was positive 10. And here it was plus 20, but the answer was negative 20. So in factored form, like you see here, the solutions are the opposites of these two numbers. Okay. Okay, so there's 3 steps, and I recommend you guys write these 3 steps down now so you can follow along. The first step is set equal to 0. So for that last problem, we didn't have to set it equal to 0 because it was already equal to 0. Oh, I hope it's not like this. No, it should be fine. All right. The second step is factor completely. And then the third step is solve each factor. So there's 3 steps to solving a quadratic using this method. Set the function equal to 0, factor the function completely, and then solve each factor separately. All right. So let's do one of these. So maybe take a screenshot or take a picture of this at home or whatever, if you're live. I'm going to erase this. Set equal to 0, factor completely, solve each factor. Okay, so here we have a quadratic function, and we want to find the zeros. All right, and what that means is it's asking you to find the solutions to this equation if y is 0. Okay, so when it says find the zeros, it means find the solutions. So the first thing we want to do is set the equation equal to 0, which means take this and make it 0. Okay, the last problem we didn't have to do that. It was already 0, so we're good. All right, so now the second step is to factor completely. So we want to take all of this and we want to factor it. Now the good news is this is quickly factored. What number multiplies to give us 32 and adds to give us 18? $16 and 2. Yeah. So remember, we're looking for two numbers that add to give us 32. Multiply to give us 32. And add to give us 18. It's 2 and 16. Okay, so that means we can quickly factor this to give us 0 equals x plus 2 times x plus 16. All right. Now from this point, because this is such a simple quadratic equation, we know the answers are going to be -2 and -16. All right, but they're not always going to be so simple. So I'm going to show you the process. Once you get to this step, we're going to solve each of these things separately. This is going to be x plus 2 equals 0. And x plus 16 equals 0. So what number plus 2 equals 0? -2. What number plus 16 equals 0? -16. Those are our two solutions. You can write it as 1 if you want, using brackets or nothing. -16, comma -2. That's it. This is our answer. Answers. There's two answers. Okay. Now, how can we be sure that we got the correct solution? We need to check it. We need to plug it back into the equation and make sure that it fits. And this is an important thing to do because it just is. All right. So let's take these two things and plug it back into there. -16 is less than -2. The smaller number goes first. Yeah. So I'm going to check it. I'm going to plug. Let's start with -2. What is -2 squared plus 18 times -2 plus 32? -2 squared is 4 plus -32, -36, sorry. plus 32. Your answer is going to be 0. And that's what we wanted. We wanted a number that would give us 0, right? Okay, so that definitely works. I'm not going to do negative 16 because I don't feel like squaring it and doing all that, but if you plugged it in there, you'd end up with 0. Now, if we graphed it, we graphed this function with these zeros, where would my x-intercepts be? They would be at positive 2 and positive 16. Now, I don't know how far down it's going to go. It could do that. It could be like this. It could be like this. That was a really bad one, but you understand what I'm saying. Could have been like this, right? We don't know exactly what the function looks like, but that's not what we're doing here. We're just trying to find the x-intercepts. All right, so those are our x-intercepts. All right, now, what would we need to know in order to graph this one appropriately? What else do we need to know? Mr. Mylan, what? Why was it positive when I graphed it? Well, I didn't really think about whether it should have been positive or negative. You mean why was it opening up? Mr. Mylan, why was it positive 2 and positive 16? Oh, I see what you're saying. Because you're right, it shouldn't have been. It should be negative 2 and negative 16. Thank you, Tahani. It should have been negative 2 and negative 16. Good catch, thank you. All right, so what other information do I need in order to graph this function? Well, I know it's going up, right? I know it's opening up because A is positive. I need to know another point, right? You know, what other points are there? Well, I could find the y-intercept, right? And the vertex, good. So the vertex is the most important point. The y-intercept helps us. So I could quickly add the y-intercept. What is the y-intercept here? Not 0. (32). Good. Remember, the y-intercept is the c. All right, so the y-intercept is way up here. I'm just going to put it here and call this 32, even though it's not accurate. All right, now, how do I find my vertex? So I know my function is going to look something like this, right? But how far down am I going to go? That's the question. I need my vertex. Well, we know how to find the vertex, all right? So if you needed to graph this, you could just find the vertex using what we learned last couple of weeks, which is negative b over 2a, right? And then negative b over 2a. This is negative 18 over 2 times 1, which is negative 9. Okay, that's my x value, my vertex, right? How do I find my y value? I'm sorry. Yeah. How do I find my y value? I plug that in to this function and solve for y. So I'd plug negative 9 into here and I'd get negative 9 squared, which would be 81, and then 18 times negative 9. Let me just do this real quick. I don't know this in my head. 162. This 18 times negative 9 would be negative 162. Minus the 81, which is negative 81, plus the 32, which would give me negative 49. So my vertex would be way down here at negative 49. Okay. Obviously, this is not drawn to scale, so it's a pretty crappy drawing, but that's essentially how you would do that. Okay. All right. But again, the new stuff here, the stuff that we're really focusing on, is finding that negative 16 and negative 2, those zeros, those x-intercepts. Okay, this will be almost my last problem. Okay, let's find the zeros of this or solve it. All right. What's the first step? We need to set it equal to 0, right? Is it equal to 0 right now? No. So in order to get this equal to 0, I need to add 18 to both sides. And I get 5x squared minus 19x plus 18 equals 0. Okay, now, before I go on to the next step, it is possible to have one solution, and it is possible to have no solutions. All right? What would it look like when there are no solutions? Well, if there are no solutions, that means there are no x-intercepts. That means it would look like this. Okay, so it's possible that the line will never cross the x-axis, and therefore there are no y values when there are no x values when y is 0. It's not possible, okay? So we say that's no solution, all right? Or no zeros. It's also possible that there's going to be one solution. When there's one solution, what does it look like? Well, it looks like this. It's when the line just barely touches the x-axis in one point. All right, it means when the vertex is on the x-axis. That is when we have one solution. All right, so what is going to happen? What's going to happen to my my function here if it's no solution? If I try to get this, and let's say that this gives us no solution, well, how do we know? Well, the answer is it won't be factorable. You won't be able to factor it. So it would be something, it just won't be factorable, all right? We'll be able to test this further when we get into quadratic formula, but just, so if this is non-factorable, that means it's no solution, all right? And we'll worry about one solution later. So anyways, this one has a solution, has solutions. I just wanted to tell you guys that. Because I do think it happens once on your homework, where you just won't be able to factor it. and it's going to ask you if there's a solution. And because you can't factor it, therefore there's no solution. All right, so let's factor this. Well, we have a problem, right? We got this 5 out front, so we can't factor it using the way we did on the last problem. So we've got to use that other method we learned, right? Can we do a GCF out of this? No. 5, 19, 18, you can't do a GCF. So we have to deal with this 5. We can't just ignore it, right? You might think that it's 1 times 18 or negative 1 and negative 18. It's not the case. All right. That would be the case if this 5 wasn't here. It would be negative 1 and negative 18, right? Because negative 1 plus negative 18 is negative 19. All right, we got this 5, we got to deal with it. So if you remember, the process is we multiply these two and we get 5, 50, 90, 95. No, 90. So that's 90. So we're looking for two numbers that multiply to give us 90 and add to give us negative 19. Let's see. If you guys have the number 9 and 10, negative 9 and negative 10. Good job, David. Thank you. Yeah. So negative 9 plus negative 10 is negative 19. And negative 9 times negative 10 is positive 90. Good. All right, so what are our factors? I'm sorry. We're factoring by grouping now, if you remember. So the 5x squared comes down. Minus 9x minus 10x plus 18 equals 0. Okay, so some of you are like, wait, what? You've got to think back to when we did this. Because of that 5, we can't just quickly factor like we did in that last problem. We have to split that middle term up and then factor by grouping. All right. Whenever a is something other than 1, you're going to have a number in front of the x in your binomials. All right. Anyway, so we split up negative 19 into negative 9x and negative 10x. Now we're going to factor by grouping. What can be factored out of there? And we'll save that for a second. So the only thing factored out of here is x. All right. I'm going to want to factor out a negative. So I'm going to factor out, let's just change the, can I change this to plus negative 10 so I don't confuse you guys? Okay. I need to factor out the negative because I want this to be a negative here. So I'm factoring out negative 10, or I'm sorry, negative 2. Equals 0. All right, and then we rewrite this as x minus 2 times 5x minus 9 equals 0. Okay. How many of you remember us doing this like two and a half months ago? We did this before all of this COVID-19 stuff. Okay, so good. So if you're having trouble with this process, just the factoring part, if you're having trouble factoring when a is not 1, look back at that video I posted for this stuff. Or go back in your textbook or back in your notes. Shouldn't it be 5x? Yeah, thank you. Thank you. Okay, so we're not done. What are we doing here? We're solving. All right, so the first thing was to set it equal to 0. We did that. The second thing was to factor it completely. Is this completely factored? Yes. All right, the third thing is to solve each factor separately. I'm going to erase all this stuff and I'm going to rewrite this up here, okay? So, what I've done is I've changed this equation into this one. It's equal to 0 and it's fully factored. Now I need to solve each one separately. Okay, this one's easy. What does x equal here? For this first one, what is x? 2, very good. I'm going to show you, but you can just skip and just say x equals 2 if you know what you're doing. So this is x minus 2 equals 0. We add 2 to both sides and we get x equals 2. Okay. This one we're going to have to do a little bit of work, which is fine. This is 5x minus 9 equals 0. We're going to add 9 to both sides, which gives us 5x equals 9. We're going to divide by 5. And x equals 9/5, which is possible. You don't always get a nice number. It is possible to get a fraction or an, yeah. Okay. So our answer is 5 goes into 9, 1 and 4/5. That's 1.8. So you can write it as a, I don't know, I think it wants it as a fraction on your homework. So just leave it as 9/5. X equals 9/5 and 2. That's your answer. Okay. Any questions so far? Okay. Now we're going to work backwards. So if I asked you to graph this, you would plot 1.8 and 2. Those would be your x-intercepts. And you would use, what was it? Positive 18 would be your y-intercept. And then you would have to find your vertex. And then you'd have your graph. So now we're going to work the other way. What happens if they give us the graph and they want us to come back here in factored form? You know, I really don't care. Hold on a second. Yeah, let's just do it once. Okay, so for this problem, we have a graph, and I know it's drawn poorly, but this is -4, 0. That's your x-intercept. So our solution is -4 and 3. This is 3, 0. That's our other x-intercept. And our vertex is -1, -12. And the question is, well, what is the function for this graph? And to put it in factored form. So not only do we want the function, but we want the function in factored form. It needs to be fully factored, right? Okay. So how do we do this? All right, so we know that it's going to be something like this. 0 equals something times something, right? And I'm just going to add this in here. There's something out front, a. All right. Now this is going to be x and x. All right, now what goes here and here? Are zeros, right? -4 and 3. All right, now remember, this is why I got confused earlier to Hanny with when I had those positives and they should have been negatives. These are the zeros, but when they're in these parentheses, they're actually the opposite signs. So it should be 4 and 3. All right, because when you solve these, you get -4 and 3. So here, this is going to be +4 and +3, -3. Okay. Now, we need more information than just these to have a nice, accurate description, right? What does this A do? This A tells us whether it opens up or down, and it tells us how skinny or wide it is, right? This A has a lot to do with the vertex. So how do we find A? Sorry, this is F. How do we find A? To find A, we're going to take the vertex and we're going to plug it in for x and y, and we're going to solve for A, and that's going to tell us what A is. All right, A is important. A tells us the shape of the function. So this part was easy. We just take our vertices, our zeros, and we do the opposites and we put them in here. Okay. Finding A, we need to take the vertex. We plug -1 in for x and -12 in for y. So this becomes -12 equals A times -1 plus 4 times -1 minus 3, and then we just solve for A. -1 plus 4 is 3, and 3 times -4 is -12, so this is -12 equals A, -12A. So A ends up being 1, which is fine. It's not always going to be 1, but in this case it is 1. So if A is 1, our function is f of x equals 1 times x plus 4 times x minus 3. Okay, now you don't have to write that 1 in here. It's not needed, but I'm putting it there just so you know it's 1, okay? All right, any questions? So for this, you write this form here, and you fill in your zeros, your x-intercepts, and then you solve for A by plugging in the vertex. Okay. Any questions? Nope. All right, you guys, just a heads up. There's one thing I didn't go over because I don't think I need to. I think you can figure it out on your own. But it's example It's example 3 on page 364. It's just an application problem, but it uses the same stuff that we learned. So example 3 on page 364 is what I didn't cover, but again, I covered all the skills you need to do it. So just read through that example and you'll be fine. All right? See you guys next week for our last meeting. Adios.